Stars do not actually fall in the same way objects on Earth do. The phenomenon commonly referred to as a falling star or a shooting star is not a star at all, but rather a small particle, typically a grain of dust or a tiny rock, that enters Earth's atmosphere from space. When these particles collide with the Earth's atmosphere, they undergo intense heating due to the friction caused by their high-speed entry. This heating causes them to become incandescent and create a glowing streak of light across the sky. The streak of light is what we observe as a falling star. The technical term for this event is a meteor. Meteors are commonly seen as brief flashes of light, lasting only a few seconds, before they burn up completely. Most meteors are relatively small and are vaporized in the atmosphere long before they could reach the Earth's surface. The reason these particles appear to fall is that they are following a trajectory towards the Earth's surface under the influence of gravity. However, due to their small size and the Earth's thick atmosphere, they are rapidly slowed down and eventually disintegrated by the atmospheric pressure and heat. It's important to note that stars, in the astronomical sense, are massive celestial objects composed of superheated gases, such as hydrogen and helium, which generate light and heat through nuclear fusion reactions. Stars are incredibly distant from Earth and are held in place by their own gravitational forces. They do not fall or move across the sky in the same way as meteors or shooting stars. Certainly. Let's delve further into the process of a falling star or meteor. When a small particle, such as a dust grain or a tiny rock, enters the Earth's atmosphere, it encounters a rapidly increasing air resistance. The particle's high velocity causes the air molecules in its path to compress and heat up, resulting in a glowing trail of superheated gas known as plasma. This glowing trail is what we perceive as a shooting star. The intense heat generated during atmospheric entry causes the meteoroid, the term for the particle before it enters the atmosphere, to undergo ablation. Ablation is the process of material being eroded or vaporized due to the extreme heat and pressure. As the meteoroid ablates, it sheds layers of material, creating a glowing tail that trails behind it. The size and composition of the meteoroid influence the characteristics of the meteor. Smaller meteoroids tend to burn up more completely and are often observed as quick streaks of light across the sky. Larger meteoroids may survive longer in the atmosphere, creating a more prolonged and visible trail. The brightness of a meteor, or its apparent magnitude, is determined by various factors, including the size of the meteoroid, its velocity, and its composition. Some meteors can reach incredible brightness, even rivaling the Moon or Venus in the night sky. These are referred to as fireballs or bolides. While most meteors disintegrate entirely in the atmosphere, some larger meteoroids can survive the journey and impact the Earth's surface. When a meteoroid reaches the ground, it is then called a meteorite. Meteorites can provide valuable scientific insights into the composition and history of our solar system. The best time to observe shooting stars is during meteor showers, which occur when Earth passes through a stream of debris left behind by a comet or asteroid. During these periods, the number of visible meteors can significantly increase, offering a captivating celestial display. So, while stars themselves do not fall, the captivating sight of a shooting star or meteor streaking across the night sky is a result of tiny particles from space entering Earth's atmosphere and creating a luminous display through friction, heat, and ablation.